if you have known this function f(x) equals absolute value of x, you are asked to figure out this transformed function absolute value 1 over 4x. You can consider the question like this. Of course, you can regard this absolute value function as an extended base function. Okay, this function we need to consider this function in different situations. First, for this function, its domain x should be real number. But for different situations, this function's expression can be changed to different expression. X is a positive number or equal to 0, f(x) equals absolute value equals x itself. If it is positive number, this f(x) equals this x itself. If it is 0, this x equals 0, that will say equals 0. If x is a negative number, this function equals the opposite number of x. Here, this number is a positive number. So, for different situations, f(x) can be changed to different expressions. But you need to know, in fact, this x and this negative x, they are non-negative numbers. In the Cartesian plane, we can sketch the graph of this function. In the quadrant 1, x should be positive number here. That is to say, for any point on the curve, x coordinate, y coordinate, they should be equal to each other. f(x) can be replaced by y, so y equals x. For this one, y equals negative x. For this branch, every point, its x coordinate and y coordinate, they are equal to each other. 0, x equals 0, y also equals 0. So the origin is also on the graph of this function. In this quadrant, x for every point, its x coordinate should be the negative number, but the y coordinate should be the opposite number of the x coordinate, so it should be positive number. So in this quadrant, the function is graph like this. This is the graph of this function. Now, if you have known the graph of this function, if you want to get the transformed function's graph, you can compare this function with the standard transformed function expression. Okay, now we can write out gx equals a f k x minus d bracket plus c. Here, f(x), this f(x) here in the transform function, this part is just like this part. A should be the coefficient of this part. Now, for this part, the coefficient A equals 1, positive 1. So you can figure out A equals 1. What about K? K, we say, for this part, X can be regarded as X minus 0, bracket. So this part, you can regard it as 1 over 4 bracket X minus 0. Outside of this bracket, this coefficient is just K. So K equals 1. D equals 0. C equals 0. Because behind this expression, plus 0, so plus C. C equals 0. D is 0. Okay? Now, for these two parameters, we need to do transformations according to these two parameters first, before the transformations according to these two parameters. A is 1. Sorry, K is not 1. It is 1 over 4. D is 0, C is 0. D represents in the horizontal direction. We need to translate the base function. But here D is 0, that is to say we don't need to do any transformation or translations in the horizontal direction. C is 0, that is to say, on the basis of the base function, we don't need to do any vertical translation for this base function. So we just need to focus on the transformation according to this parameter k. Okay, now k equals 1/4. You know, k represents horizontal stretches or horizontal compressions. Here, k equals 1/4. This number less than 1, greater than 0. So we need to do horizontal compressions or horizontal stretches. This one or this one is decided by this number. Here, k is a positive number less than 1, so we need to do horizontal stretches. That is to say, for every point for the x-coordinate, if we want to keep the y-coordinate unchanged, we need to amplify this x0 by 4 as the factor. That is to say, on the transformed curve, the transformed x-coordinate, this x-coordinate should be 4 times x0. So x should be 4 times x0, but y0 should be the same. For every point on the base function, we need to do the same transformation. So you can figure out the new transformed curve should be like this. For the left branch, we need to do the same transformation according to this horizontal stretches. That is to say, for this point, we want to keep the y0 unchanged. Here, x0, we need to do the same transformation. That is to say, the new x-coordinate should be got from 4 times x0. So it should be here. But you need to know x0 on the left x-axis, it should be a negative number. So 4 times x0 is also a negative number. Y0 unchanged. So for this branch, the transformed curve should be like this. For the right side, the transformed curve like this. Okay, so we can figure out if here is 1, here it should be 4. Okay, 4 should be closer to the 0. So we assume here it is 4. Now it is -1. It should be -4. This point should be here. Okay, we can figure out the left transformed curve should be like this. This is the gx equals absolute value 1/4 x. You need to know this transformed function, its graph should be composed of this right branch and this right branch. Okay, this is the transformed function of gx. For this transformed function, domain also x should be any real number. We don't need to add any restrictions for the domain.